Good morning, everybody. Can you hear me now?
Good morning. Yes, Professor.
Good morning, Marley. How are you? Good morning, everybody. Um, can you hear me?
Yes, I
Okay.
hear you.
Yes, Professor, we can hear you.
All right, please. Thank you. So, just want to make sure that we're going to have our midterm exams this Thursday, I believe, and I wanted to today. I wanted to do reviews, um, and then I posted the review guideline on the announcement section, and I wanted to go over with the review guideline today. I don't want to start a new chapter. I'm sure that for a better understanding, excuse me, for better understanding and better communication, it's good if you can able to download the review guideline. That would be very helpful. It's on the announcement section. I downloaded myself here. Came on a one midterm exam review spring 2021. um, so yes, so we're going to go ahead and I'll tell you what questions that you expect during these are the highlights actually. The questions are basically multiple choice questions and true false, and they're going to be an they're going to be in a canvas as we did last time, and you have to open them with a lockdown browser, just like the same format that we used to do. Once you downloaded the lockdown browser in the first exam or in the lab exam, then you don't have to do it again, because that's a situation that when if you like to download twice or three times, there's going to be um, a bit big crash, and that's not good. That's not good. Okay. Um, so the other thing that I wanted to say that please don't use iPad or tablets or your iPhone. I don't know. I honestly, it doesn't work. It doesn't work. I'm trying to help a couple of you, and you know that, and but I'm not the IT person, and where everything is online. You don't get enough help at the same time. I can understand this frustration. So try to have a laptop or a desktop. So and then we need to get the also we need to get I think the best engine search is Mozilla and Chrome. These are the best things that are very friendly with the uh, with the lockdown browser. Okay, so try to accommodate yourself with the laptop or with the screen desktop. And I know we are very tight in moving from one place to the other place. So many places are closed, but I don't suggest to use iPad or tablet or your cell phone. It's not working. It's not working. If you have if you know any IT geek and any IT person who can assist you, please do. I don't have any problem. I really I just want to make things easier for you. But these devices are not friendly with downloading the with the lockdown browser. So what type of questions are we expecting during this Thursday exam? These are the highlights, and if you have any questions or in anything, you can also text me, and we can also chat on the text, and I'll stay after the class. But these are the main points that you need to know during the exam. From the first chapter, we will be there's questions regarding with identifying the difference between mixture and compounds. You know, what's a mixture, what's a compound. When we say mixture, you have to look topics, slides of mixtures, like homogeneous and heterogeneous mixture, and what's a pure substance. So these are the points that we need to discuss. You need to focus during your study, and you need to identify the difference between physical and chemical reaction or physical and chemical change. Also, know the difference between intensive and extensive reporting. Okay, So you have what's intensive property and extensive property. They are also be discussed in chapter one. Intensive is no, intensive doesn't depend on the quantity or the material that you have, and extensive depend on the quantity. Like good example of intensive is going to be density is a good example, boiling point is a good example, and extensive when the quantity, the amount changes, the property changes, like pressure, volume, heat, stuff like that. So this is clearly discussed and covered on chapter one. And also know the formula of converting Celsius to Fahrenheit, how to convert Celsius to Fahrenheit, Fahrenheit to Celsius, Celsius to Kelvin. Example, you have to make a practice. Just give a number for yourself, like you may have, let's say, a number like um, put like I would say what's that? Just put 15 degrees centigrade, and you wanted to convert 15 degrees centigrade to Kelvin, or you want to change 15 degrees centigrade to degree Fahrenheit. Okay, so there's a formula. Kelvin equals centigrade plus 273.15, and there's also another formula if you have centigrade and you want to get the Fahrenheit value is going to be 9 over 5 degrees centigrade plus 32. So, converting from Celsius to Kelvin, it's straight and forward. You can able to convert it right away. But something like Fahrenheit to Celsius, you have to multiply by 9 over 5 times Celsius plus 32. So one thing that we also have to take into consideration when you do a mathematical operation, do the multiplication part first. Remember that multiplication, and then comes division, and then finally addition. Okay, so just follow the rules. So you have to multiply 9 over 5 times 15 plus 32. So 9 times 15 over 5 plus 32 to get the right number. So sometimes, and one thing that I wanted to say during exam, please don't expect exactly the answer. Let's say that the answer that you get when you do the calculation is 25.7, okay, degree Fahrenheit. Okay, so when I wrote or when I generate the question, we all are human beings. We all made mistake. You have to understand that. So you don't get 25.7. You may get 26. Okay, so take 26. Don't expect that. Oh, it must be 25.7. If there's the closest answer, you have to take that closest answer. I'm saying this from experience. Actually, I don't know, because sometimes I have question. Oh, professor, I don't have that answer on the choice. But yes, the calculator display shows you 25.7. You may not have that answer exactly 25.7. It might be rounded up. The person who generated the test, he likes to write, or he or she likes into two significant figures. She might or he might round it to 25.7 to 26. So be mindful that get as far as you get the closed answer, that's fine. So think about that way too. So these are the questions, and um, what is it at? Okay, so review guideline. Okay, so also practice how to balance a chemical equation. Okay, we have to also learn balancing a chemical equation. Okay, so balancing a chemical equation we discussed in chapter 2 and some part of chapter 3.
Professor,
Yes, yeah.
I don't see any question on my screen.
Huh?
I said I don't see any question on my screen.
What do you say, Matt? You don't say anything?
I don't see nothing.
Um, I didn't share anything. You guys didn't see?
You share, but you're talking about question. I'm seeing the chapter 3.
No, Matt, Professor is just giving some sample questions that may appear in the test on the exam.
Oh, okay. Thank you.
Yeah, yeah. We do review guidelines today, so I'm doing reviews, and then the review guideline is also on the announcement section. Just let you know, Matt, it's on the announcement section. So I'm just reading what you have from the review guideline. I'm just exploring the point. What this is like a GPS for you to what points that you need to focus. So let me go ahead and. So like the other question that we may have questions like how to learn how to balance a chemical equation, okay? And like for example, we have here C3H8 react with oxygen gives you CO2 plus water, okay? Can you see what, do you see what I'm writing? Everybody? No?
Yes.
Yes.
Okay, wonderful, wonderful. So if you see it, everybody will see that. Okay, so one thing that we need to know, there is no like strict rule for balancing the equation. There is and there is no. So it's confusion. If you have a polyatomic ion involved, polyatomic ion means that like if you have sulfate ion or nitrate ion, something like that, you have to treat them as one unit, as one, just like how many sulfate ion you have, how many nitrate ion you have. So do a polyatomic ion first to balance the equation. That's my advice. Like SO4, don't try to balance sulfur or oxygen SO4 as one unit because that's a polyatomic ion. Nitrates as one unit. Okay, if you have phosphate, for example, phosphate is considered as one unit. There's one phosphate, there's two phosphate, there is three phosphate, depending on that. Okay. However, this is a situation when you have a polyatomic ions are involved. When you have polyatomic ions, do the polyatomic ions first, or balance the polyatomic ions first. Okay. Uh, that's like as a tip. But stuff like that, when we wanted to balance the equation, C3H8 plus O2 gives you CO2 plus H2O. There is no polyatomic ion here, so you have to count the individual number of atoms. You have like 3 atoms of carbon, 8 atoms of hydrogen, 2 atoms of oxygen. On the reactant side, you have like 1 atom of carbon, 3 atoms of oxygen, and 2 atoms of hydrogen on the product side. This is reactant, this is product. Okay, so in this case, you need to the trial and error method. Okay, so you can say that, okay, wait a minute, I have 3 atoms of carbon, I have only 1 atom of carbon. It's not balanced. What is the important thing in balancing a chemical equation? The important thing in balancing a chemical equation is using something called coefficient. Can anyone tell me what coefficient is, please? What is coefficient? Coefficient, what's it? It's a number. Can I have someone maybe tell? It's a number.
But
That,
a number that goes in front.
Emily, is that Emily?
Yes. Is that a number that goes in front?
And numbers that you put in front of a chemical formula. That's the only numbers that you're going to use to balance a chemical equation. Thank you, Emily. So I have like 3 carbon here. I'm going to put 3 here in front of CO2 to balance carbon. I have 8 hydrogen here on the reactant side. I have 2 hydrogen here. So what number should I put here in front of H2O to make it 8?
5.
4.
4.
4. Because 4 times 2 is 8. All right. Now, you see coefficient. Now look the number of oxygen on the product side. How many oxygen you have on the product side? On the product side, how many oxygen you have?
1.
Oxygen on the product side.
2.
3.
How many oxygen you have on the product side?
2,
7,
No,
7,
no,
2,
no,
3.
no,
No? Oh, wait. 7.
1.
6.
1,
no. Can you hold for a second, please?
Oh, I'm sorry. Okay. 10. I'm sorry. They're 11. 4, 4. Yes. 6 and 4. No, I'm sorry. They're 10.
Marlene.
Yes, they're
So can you
10.
say one more time?
10,
Yes, it is 10, ladies and gentlemen, it is 10. I
3
want you to
times
think
2.
about this. There is 10 oxygen on the product side. I want you to think about it. How can you explain, Marlene, please, how you came up with that number?
Um, where the 3 CO2 is, it's 3 times 2, which is 6. And then where it's 4, it's 4 times the 1. And 6 plus 4 is 10 on the product side.
It's 10, right?
Yes.
The reason why it is 10, I want you to look here. There is, oh, excuse me. 3 times 2, there is 6 oxygen here, plus 4 oxygen here from the water side. So there's going to be 10 oxygen on the product side. So to make it 10, to make it equal, what's the numbers that you're going to put in front of O2?
5.
5. 5, okay? That's how we balance the equation. That's how we balance the equation. Also, learn about the different types of chemical reactions. Okay, here I have listed the type of chemical reactions for you that we have. A combination reaction, single replacement reaction, double replacement reaction, decomposition reaction, metathesis reaction. Actually, chapter 2, there's one big slide. If I don't make a mistake, someone can correct me. Um, that slide number 55, I believe, tells you all the different types of reactions. So make a practice with that too. So balancing the equation, like I say, is a trial and error method. Calculates molecular weight and formula weight of the compound. So again, when you do this problem, you need to have a periodic table with you. I don't want to tell you this over and over. By now, everybody knows the significance of having a periodic table. So I don't, Matt, I see the text. You cannot hear me, you guys? Matt and Morgan, you guys cannot hear me? Or can you
I
guys
can hear
hear me?
you.
What's wrong?
I was saying that we could hear you.
What's that, Matt?
Yeah.
Morgan?
I was saying that we can hear you.
You cannot hear me?
I can hear you. We can hear you.
Okay. I saw some text that, so I thought I was talking
Yeah.
to myself.
No, it's me because I don't know. It was breaking out, so I don't know. I thought you were not talking anymore.
I'm talking. Matt, I think maybe the connection, maybe you can log out and log in. I think I'm talking so far.
Okay, I'm gonna log out.
Yes. Let's do it that way. So when you use formula weight, we use formula weight for ionic compound, okay? For ionic compound. And molecular weight, we use molecular weight for covalent compound. So just give me a minute and I'm going to so we use a formula weight for ionic compound and molecular weight for molecular weight for covalent compounds, right? So I'm just trying to give you an example. Say, for example, I have CaNO3 which is, what is the name of this compound? Can anyone tell me the name? CaNO3. Can you see what I'm writing right now?
Calcium nitrate.
Calcium nitrate. Calcium nitrate. Calcium nitrate. Yes. So calcium nitrate. So is it ionic compound or molecular compound? So I want you to see the difference between calcium nitrate and maybe, like, let's say that I would put I would put C6H12O6. Okay. So I want you to calculate the two and give me the answer. Okay. C6H12O6. One is ionic compound, the other is covalent compound. But in order to do the calculation, you need to have a periodic table with you. So once you have a periodic table, it's easy to calculate. But I can give you about 3 to 5 minutes to calculate this, and then I need the answer from you. Okay, how about that? Do you guys hear me?
Yes, Professor.
Yes,
We can
Professor.
Okay, thank you.
I'm still wondering who you stole that bus from. Who the
No, hello, I'm so sorry. Hello? Can you guys hear me?
Yes.
Yes.
Okay. Okay, thank you. Thank you very much. Some disruption is here. It's the just like I say, just to save our time, formula unit, when you do calculation in ionic compound, you call it formula unit. For example, I don't have a predictable, but I can just say that calcium is 40 approximately. You have nitrate here, you have 2 times 14, and you have 6 times 16. Okay, so all this will be added, and then you can get the number. That number is called formula weight. That's just a matter of saying we use formula weight for ionic compounds. We use molecular weight for covalent compound. So again, it's a term. It's a matter of term. So we have 6 times 12 as for hydrocarbon, 1 times 12, that's for hydrogen, 6 times 16, that's for oxygen. So you added them up, 6 times 12 is 72, 12, and this guy would be 96. So about 180, sorry, 180. So that's going to be the molecular weight. So we use formula weight or molecular weight, depending on the type of formulas that we use. Okay. Um, and then the other thing that you should expect, if there's any question, please let me know. Uh, about calculate molecular weight, no, empirical formula and molecular formula, okay? So we did a lot of calculation with using molecular formula and empirical formula. So many examples was done in chapter 3. So I want you to take into that. But one thing that I would like to say, let's say that I have C6H12O6. This is called a molecular formula, okay? Now, how do I know that? Because it represents the actual number of atoms in a molecule, right? If I factorize this, then I would have to say, like, if I factorize this, or if I calculate the lowest whole number ratio, okay, so it's going to be CH2O. Okay, that's the lowest whole number ratio. The lowest whole number ratio, that's called empirical formula. Okay, empirical formula always tells me the lowest whole number ratio, whereas molecular formula tells me the actual number of atoms, the exact actual number of atoms in a molecule. So that's the difference between empirical and molecular formula. Um, and then the question here, calculate the percentage composition by mass of a single element from a compound. Okay, what does that mean? So for example, I have a compound here, um, calcium nitrate. Okay, calcium nitrate. You may have a question to ask it here. Calculate the percentage composition of uh, of nitrogen in calcium nitrate. Calculate the percentage composition of nitrogen in calcium nitrate, for example, you see? So if you have a question like that, calculate the percentage composition of nitrogen in calcium nitrate. So what do we have here? You wanted to calculate the percentage composition of nitrogen. So percentage of nitrogen is going to be the weight of nitrogen divided by the formula weight of the entire compound times 100%. Okay, so percent of nitrogen, the weight of nitrogen divided by the formula weight of the compound times 100. So the nitrogen, how many nitrogen we have? We have 2 atoms of nitrogen. 2 atoms of nitrogen in weight would be about 28 grams over the formula weight of the compound. See, remember that now, this time I'm calculating the percentage weight of a single element from a compound, okay? So 28 gram over formula weight of the compound. The formula weight of the compound, I have to calculate the formula weight. So calcium is 40. Can we calculate together the formula weight of calcium nitrate? Calcium is 40. Nitrogen is 28. Okay. Oxygen is, what is the weight of oxygen? You have 6 atoms of oxygen. 6 times 16. What does that gives you? 6 times 16 is 96. 96, right? I'm on the mic, right? I'm on the mic, guys?
Yes.
Okay, so when we add 48 plus 28 plus 96, let's see, 40, okay, let's see here. We have, okay, so
160.
like we have 40 plus 28 plus 96 is going to be 164, okay? So 28 over 164 times 100, okay? So 28 divided by 28 um, divided by 164, okay, times 100, okay? So the percentage composition of nitrogen in calcium nitrate, in this case, is going to be about 17%. That's how we calculate percentage composition. That's how percentage composition is calculated. Does that make sense, everybody?
Yes,
Okay,
Professor.
wonderful. Um, and then the other question that you may have is convert moles to grams and grams to moles from the given equation as well as from the reaction. Okay, so let's say that I have given you about like, I have 1.5 moles of HCl, convert into gram of HCl. Okay, that's the question. Or someone might ask you, okay, I have 258 grams of sulfuric acid, which is H2SO4, converts that into mole of sulfuric acid. So again, if you have questions like this, what you need to do is first you need to find, for example, if this is A and if this is B, you need to calculate what is 1 mole of HCl equals to. 1 mole of HCl equals to about 36.5 grams of HCl. Okay, now how do I know that? Again, my reference is periodic table. So hydrogen is about 1.008 grams approximately. Chlorine is 35.5 grams. So if you add this up, you get about 36.5 grams. So that's for 1 mole. So now they want you to calculate the 1.5 moles. So 1.5 moles of HCl, you multiply this by, always, if you want to change grams, moles to grams, the gram has to be on the top. Always the desired unit, that's a key part here when you do conversion. The desired unit has to be on the top. So 36.5 grams of HCl over 1.0 mole of HCl. Okay, so you do the calculation, the unwanted unit will be treated out, and then you multiply 1.5 by 36.5, and then you can get the answer that way. Please make sure that when you start the exam, because the exam is timely restricted, you got to have a periodic table next to you. You got to have a calculator, a good calculator, a functionable calculator next to you. Okay, so I have my cell phone here. I multiply 1.5 times 36.5. So this gives me, if you have a different answer, let me know. But I got 54.75 grams of HCl. Okay. Also, significant figures are very important in this case. So Please don't be tricked with significant figures. So if I have 1.5, I would say 1.50 mole of HCl. So I put 1.50 mole of HCl to make this as three significant figures. So I have 54.7 grams of HCl. Okay, so so that should be the answer. As far as concerned with B, so you have been given 258 grams of sulfuric acid, and you wanted to convert that into monosulfuric acid. Okay, again, we need to calculate first what is 1 mole of sulfuric acid equals to. So again, can anyone tell me the molar mass of sulfuric acid, 1 mole of sulfuric acid? We can do this together. A hydrogen has 1, right? You already have that. Sulfur has 31 or 32. Can anyone tells me?
32.
32, thank you very much. Sulfur has 32. I know oxygen has almost 16. So this is going to be 2 times 1, that's for hydrogen. 1 times 32, that's for sulfur. 4 times 16, that's for oxygen. So we have 2 plus 32 plus 64. So 2 plus 32 plus 64, that gives me 34 plus 64, that gives me 98. 98, right? So 1 mole of sulfuric acid is 98 grams. So if that's the case, then how many moles you have in 258 grams of sulfuric acid? You see, so what you can do here is that okay, 1 mole of sulfuric acid, we already calculated, it gives us 98 grams. So if you have 258 grams, how many moles do you have? Okay, so again, we do a calculation, 258 grams of sulfuric acid times 1 mole of sulfuric acid. Remember, the desired unit has always been on the top, okay? Over 98 grams of sulfuric acid. Okay, so the unwanted units will be cancelled out. Then what you have to do is you just have to divide 258 by 98. Okay, so that gives you the number of moles. Remember that we're looking for the number of moles. Desired unit. The ones that you're looking for, desired units, they have to be on the top. Okay, so that is 258, 258. So you can say that you got 258 would be divided by 98, about, I would say, 2.6 mole of sulfuric acid. 2.6 mole of sulfuric acid. That's how we calculate the density. I mean, we convert moles to grams, grams to moles. Know how to know about how to calculate density. That's also I think we talked about density in chapter 1. So remember about the formula for density equals mass over volume. This is like the original formula. From here you can also calculate mass equals density times volume. Also you have volume equals mass over density. Practice examples were given regarding with this. You can look on that and make a practice as well how to do the calculation. Always a good practice to me is that always you have a piece of paper next to you, write what is given, what that you have. That's important. What that you have, write those down, the one list what you have, and then from that base you can move forward. You can move forward. And then you have on one side, let's say on the left side, you have the given value. On the right side, you have the wanted value. So you know what is given and what that you're looking for. And based on that, you can calculate whether looking for density or whether looking for mass or whether you're looking for value. You can make you can manipulate. You can manipulate based on what you're looking for. Questions again that here, know how to find the product if the value of the reactant will be given. This is a limiting reactant problem, particularly if two values of reactants will be given, then it's a limiting reactant problem. So a limiting and excess reactant will also be a part of the question. And last time I remember you remembered that I I have given you quite analogy that when if you want to make a sandwich, which is the formula for sandwich is like you have two slices of bread and cheese. I put two as a subscript, so that's two slices of bread and one cheese. Okay, so like if I gave you about 10 slices of bread, okay, plus 7 slices of cheese. Okay, so when we do the calculation, how many sandwich are we going to make? So if you have 10 slices of bread and then 7 slices of cheese, and how many sandwich are we going to make? Okay, this if two values are given as a reactant value, this is a reactant, this is a product. So this is a limiting reactant problem. I have given you examples related with limiting reactant problems, okay? So please focus on those examples. The key part in the limiting reactant problem is to identify which one is a limiting value, which one is excess value. That's very important. Once you determine, then the reason why we need to know which one is limiting and which one is excess, that would help us to determine the amount of product. So that will help us to determine the amount of product, how much products that we get. That's very important for us. If we get that way, we can able to, if you know what's the limiting reactant and we know the amount of product, okay? Of course, there's an example here. For example, we have I don't know if this problem was done during the lecture, but this is a good practice here. When 2 grams of striped zinc metal is placed in, you have again from this is from the review guideline. I see that you have zinc react with silver nitrate, it gives you silver plus zinc nitrate. Okay, so given that you have 2.50 grams of silver nitrate, okay, you also have given 2.00 grams of zinc. Now, just by looking up the values, this is a limiting reactant problem. This is a good thing that you need to know, a limiting reactant problem. Okay, because you have two values from the reactant. One is 2.5 grams of silver nitrate, the other is 2.00 grams of zinc. So one of the reactants is limiting, the other is excess reactant, okay? So in a situation like this, what is the first thing that you have to do? The very first thing that you have to do, what's that? Before addressing or before answering, which is a limiting reactant? Anyone can tell me what's the first thing that you have to do?
Convert the grams to moles.
I'm sorry?
Convert grams to moles.
Before that.
You identify which is a limiting and which is a excess.
before that. I both of
Balance
them
the
are right.
equation.
I'm sorry.
Balance the equation.
I'm sorry.
I said, do we have to balance the equation first?
Exactly. We have to first balance the equation. We have to first balance the equation regardless. Then you can convert the gram to moles. And then the second point, I think Adimola or Matt, I don't know who says the second point, he said that identify which is the limiting reactant. But prior to everything, this equation has to be balanced. Now, do you think this equation is balanced? That's my question.
It's
No,
not because
It's
we
not.
got
It's not. Okay. So if it's not, then what do I have to do?
we have to balance using coefficient.
Okay, go ahead. Let's balance this equation. Remember, I told you that when you have using coefficient, excellent. Using coefficient, I like that. The coefficient is a keyword here, but you also have to think in a situation to make the equation balanced. You have to first start balancing with the polyatomic ion, So
uh,
look for nitrates. If anybody wants to help me, I appreciate that. Marcus or anyone, I'm just writing what you said. Then I can
okay.
able to. Yeah, go ahead, please.
So to balance this one on the reactant side, I would put a coefficient of 2 before the silver nitrate. And then
Uh-huh.
I said to balance this one on the reactant side, I would put a coefficient of 2 before the silver nitrate.
Uh-huh. Uh-huh.
And then for the product side, I would put a coefficient of 2 before silver.
On the product side, you put 2.
Right, before silver.
Okay. Okay.
And I'm putting the 2 before the silver nitrate on the reactant side too.
Yeah. Yes. Because here we have 2 of the nitrate. So to balance that, we're going to add 2 here. To balance the nitrate. To balance the nitrate, the entire nitrate. Okay, you have 2 nitrate here. And then you have to put 2 a coefficient here. But putting 2, you change the amount of silver to 2. So we have to put another 2 here. So that's how the equation is balanced. That's the very first thing that we need to do. Okay, that's the key part. Then the next part is we're going to decide which is a limiting reactant, zinc or silver. I mean, zinc or silver nitrate. That's the work that we have to do. You see, zinc or silver nitrate. So how do we determine which is the limiting reactant? We did this example, I believe, in class, but I think this time maybe I heard Marcus say that, oh, I can convert this into moles. You don't have to though, but you can. And it depends. Some people like a mole to mole ratio. Some people like mole to mole ratio, convert the grams to moles. That's fine. I don't have any problem with that. I personally, I can do both. I can just compare the grams of zinc with a gram of silver nitrate because the values are given in grams here. You see, so what I'm going to do is that. It's just a matter of saving time. That's all. It's just a matter of saving time. So whichever way you like, but determine the limiting reactant, whether the limiting reactant is silver nitrate or zinc. Once you answered part A, which is the limiting reactant, then it would be easier to work with the amount of product. In this case, they gave you the question: how many grams of silver will form? The amount of silver that's forming. The amount of silver that's forming determined by what? Determined by the limiting reactant. By the limiting reactant, your limiting reactant, like I say, it can be silver nitrate or it can be zinc. Okay, so you may can say that The amount of zinc, what is the weight of zinc? From the periodic table, I believe zinc is 65 grams, maybe more or less, right?
Yes.
65 grams of zinc react with, we need to find the molar mass of silver nitrate. Again, I want you to calculate the molar mass of silver nitrate. What is the molar mass of silver nitrate? You can calculate the molar mass of silver nitrate. Take into the consideration that silver is 108 and nitrogen is 14, oxygen is 16. Okay, remember that you have 3 atoms of oxygen. So 108 plus 14 plus 16 times 3, 16 times 3 is 48. So we do have we have here let's see, 108 plus 14 uh, plus 48, that's 170 to me. If anybody has a different answer, please let me know. 170 times 2, that gives me 218. 218 grams of silver nitrate. So 65 grams of zinc corresponds with 218 grams of silver nitrate. So if I have 2 grams of 2.00 grams of zinc, how many grams of silver nitrate I would get? I can do this calculation. Why I have to do this calculation is to determine the limiting reactant. This is for a purpose of to determine the limiting reactant.
Professor, where you
Yes.
get a 218?
Huh?
Where you get a 218?
Do you have a predictable with you, Matt?
Yeah, I do.
Okay, so what is the weight of silver? It's 108, right?
Yes, 108.
Okay, 108 plus 14, okay, plus 48.
Okay, all right. Yes.
Yeah, 108 plus 14 plus 48. That's 170 times 2. All right, that's how to 18 I get, right? Okay, so so I have to make a calculation here. Okay, so 2.00 times 218 over 65. So that gives me the amount of silver nitrate, which is X. That would be corresponding with 2 grams of zinc. Okay, so 2 times. So anybody can have calculator. We can work this together. Okay. So 2 times 218 is 436 divided by 65. I got 6.7 grams of silver nitrate. So you see here, this is a comparison for you. 6.7 grams of silver nitrate and 2.50 grams of silver nitrate. You see, that gives you something. For 2 grams of zinc, you may need exactly how many grams of silver nitrate? For 2 grams of zinc, according to the calculations that we did here, you need 6.7 grams of silver nitrate. So if you have, but they gave you 2.5 grams of silver nitrate. So which is the limiting reactant then?
Silver nitrate.
Silver nitrate, because you don't have enough amount. For 2 grams of zinc, you must need 6.7 grams of silver nitrate, but unfortunately that's not enough amount. You have been given 2.50 here. So that's how limiting reactant will be determined. So which is the limiting reactant? In this case would be silver nitrate. You answer the first question. Then the rest will be easier. Once you determine the limiting reactant, so you can compare the amount of silver that's produced or the amount of zinc nitrate that's produced. You can make a comparison that way. Okay, so now the amount of silver or silver nitrate determined on silver. I mean on silver nitrate, because we know that now silver nitrate is our limiting reactant. Silver nitrate is our limiting reactant. Yes. Okay, so that's question number 13, 14. Question number 13, A, B, C, D will be answered that way. Also, there's a question here, identify what is a precise value and accurate value. That's from chapter 1. We can define precision and accuracy. Know the nature of subatomic particles like protons, neutrons, electrons. Identify the isotopes, and then atomic symbol should be. We did so many examples regarding with this. This is something that we covered in chapter 2, which I want you to look at that. Significant figures, always. Significant figures are also factors that you pay attention. The number of significant figures when you deal with multiplications and divisions, and the number of significant figure when you deal with additions and subtractions. Okay. Know the main difference between ionic and molecular or covalent compounds. These are very important points for chemistry, for this level of chemistry. Two things you have to know in Chem 101. I mean, it's not only two things, but everybody needs to know the difference between ionic and covalent compounds. Okay. And also you must practice with the names, name any kind of names, okay, which is called nomenclature. Nomenclature or naming system. Nomenclature, how to name compounds is very important, and difference between ionic and covalent compound. The reason why I say that in every chapter, these are included. Chapter 1, chapter 2, chapter 3, even chapter 4, 5, and 6. We're going to include that naming. About the groups like the main groups, you have a predictable who are alkali metals and alkaline earth metals and halogens and noble gases. Who are they and what makes them different one from the other? It's also a fact that we also need to know, like metals have certain characteristics that differs from non-metals, so we have to identify their characteristics. And why do metals lose electrons? Why do non-metals gain electrons? I will spend several times on that. And that also leads you with the charge of the ion. Think about this. Why is calcium has +2? Why is chlorine has -1? And why is like sodium has +1? Okay, this is related with a lot of things. This answers a lot of questions. Okay, calcium is in plus, calcium has a charge of +2. First of all, just by looking a plus sign, I can tell it's metal. Okay, it's a metallic character. And a +2 also tells me that it's in group 2. If it is group 2, it's going to be an alkaline earth metals, okay? A minus sign tells me that it's a non-metal. Whether it is -1, -2, -3, I don't care. It's a non-metal. Now, but looking on the number, whether it is, for example, O is -2, N is -3. Looking at the number by itself tells me that whether it is in group 6 or in group 5 or in group 7. You see, I have chlorine -1, it needs 1 electron, so it is group 7. I have oxygen -2, so it's in group 6. I have N-3, it's in group 5. Okay, so this is just a stretch. This is just a guideline for your exam for this Thursday. And then I'm going to take attendance now. If anybody has any question, text me or send me an email. Or the other thing I wanted to say, if you have time, you can join the 6 p.m. class too. We're going to do the same reviews. with the other class. So if you have time today, if there is no any overlapping, if you want to know more, I'm going to cover the same material. So you can also come to that class. I can send you the link, and then you can join the 6 p.m. class. We do reviews at the same time. Okay, so you can get the benefit of the two classes. I think the time is up right now. I'm going to take attendance. If you cannot speak, or if your mic has an issue, please uh, text me. Text me that, and then I know that you are here. Okay, let me. Okay, hold for a second. Olive Agini.
I'm here, Professor.
Oh, okay, Olive. Olive, I'll
Professor, I'm
send
here.
the link. I'll send the link. Okay, I'll send you the link for tonight. Okay. The link you mean for the 6 p.m. link? Is that what you said?
Okay.
I just saw a text from someone. Who's that?
Yes, Professor.
Okay, all right. Okay. Olive, are you there?
Yes, Professor.
Okay, okay, thank you. Taylor?
Here.
Professor, I'm here.
Here.
Okay, Taylor. Kimani Allen? Kimani Allen?
Here, Professor.
Thank you.
Here.
Thank you, Kimani. Shristi BK?
Present, Professor.
Thank you. Kwai Baker?
I'm here.
Okay. Julia?
Present.
Thank you. Ademola?
Yeah.
Okay. Shannon Farmer? Shannon?
Here.
Thank you. Marilyn Hamlin?
Here.
Thank you. Aisha Jenkins?
She's here.
Okay. Thank you. Thank you, Aisha. Okay, I just saw the text now. Christopher Lins? Christopher? Christopher, I didn't hear from you. Marcus McLean? Marcus?
Present.
Thank you. Miriam Mohib? Miriam?
Here.
Thank you. Martha Molua? Martha?
I'm here. I need a link too.
Okay, I'm going to send the link on the announcement section so that everybody can have an access, Martha. So that
Thank you.
everybody will have an access. Sebatu Molowi, you're welcome. Sebatu.
Here.
Andrid Ortiz, Andrid. Emily Pelton, Emily.
Here.
Thank you. Brittany Pitford, Brittany.
Brittany was here. She just texted me and said her internet's giving
Okay,
issues. So
okay,
connection.
thank you. Sky Regland, Sky.
Here.
Thank you. Lakeisha Reynolds.
I'm here.
Thank you. Angie Rodriguez, Angie.
I'm here.
Okay, Angie, okay, thank you. Android, okay, I see your text, Android. Okay, let me change that. Thank you. Charlotte Service, Charlotte also texted me earlier. Yes, Android, I see it now. Android, I just changed your present. Okay. Morgan Stanford. Morgan, okay, I got it. Okay. 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 Susan Tifu, Susan.
Present.
Okay. So just in case if I miss someone here, I did hear from Christopher Lins. Actually, I'm the only person that's missed is Christopher. Other than that, everybody is here to me. So I will send you the link for tonight, and I'll send you the review guide. The review guideline is already on the announcement section, by the way. You just have to download that. And then the link for today's Zoom discussion, and then the link for tonight's class to join at 6 p.m. Okay, so that you can get the benefit from the two classes for the reviews. All right. If anyone has any question, you can stay at the end, and then I'll take notes. Okay.
Yeah,
while I'm
there's
doing
one thing I'll
this.
talk to you about. Hello?
Yes, Marcus.
Yeah, so just one thing I want to talk to you about the lab thing you were talking. You sent me that email about.
The lab.
I do
Oh
have the
yeah, yeah,
lab
yeah, yeah,
manual.
yeah, yeah. Okay, go ahead, Marcus. Yes.
Right. Yeah, I did buy the lab manual, but I have the digital version. So since I
Say
got,
one more time.
I do have the lab manual, but I have the digital version. I got it off of Pearson, right? And they really don't let you print out the lab. I mean, they do, but it has a watermark on it and everything. So rather than printing it out like that, all I do is I type everything into Microsoft Excel and then I format it to make it look nice or whatever before I send it to you. So the version you're seeing is just basically from me typing it out.
Okay. Wow, it's amazing. So you buy this, you buy the book, you buy the lab textbook, the custom textbook from the bookstore.
Right.
And
Well,
then
not from the bookstore. I got the digital version from Pearson.
the digital from Pearson?
Yeah.
Okay, but this is a custom lab book, right? The custom one.
Right. It is custom one.
Okay, so okay, you buy the digital one. How much you pay for it?
I think it was about $40. I'm not sure.
Okay, so Pearson is okay. I thought it's only in the, okay. Was I have to tell to my students, you know. So you buy this from Pearson,
Right.
a digital.
Right. And they don't, from the digital version, they don't really, they allow you to print it out, but it prints out with this watermark on it or something. And so for me to, since I have the digital version, for me to put my work in and stuff, I thought the best thing for me to do would just be to type it in Excel so I could just type in all my answers and stuff in there.
Okay. So, okay, it's wonderful. Okay, I just wanted to find out that how it worked, and I saw
Right.
it is very clean and clear. So that's why I just wanted to find out how you did it. You know.
Right. I just typed the whole thing up from scratch. That's it.
Okay. All right. Thank you very much for that.
No problem.
Okay.
All right, later.
Okay. Bye.